Hello, today I'm going to present the 9 models I produced for Digital Making 2756. The first model is the back cover of my flip phone, where I started with a sketch of a rectangle with the rear cutout positions on the same plane before extruding. Then I did the round fillet and shelled the inside. Lastly, I cleaned out the inside remains and finished with the side cutouts. Next is the manhole cover, where the idea came along when I was having a waffle one day, seeing the patterns on top. I made an offset circle of rectangles coming out of the outer circumference to act as a hinge and positioning sections. Then I extruded them to different height, making a lip on the outside. The hinge was filleted to a semicircle for easier positioning of the hole cutout later on. I shifted it to the top plane to sketch more cutouts by extruding back down and finished by laying a pattern on top to cut in the inner circle. The last parametric model I made was a paper mill, which is produced by rotating the shape on the z-axis and shelling on the inside. I changed it to a 3-part assembly after the last class, with a finishing touch of patterning texture on the top knob. The first freeform I did was a simple spoon separated into 2 sections. Then I realized there was no history timeline in freeform, so I did a time lapse for my other 2 models. This one is a freeform chair where I spent the most time on modeling. Trying to drag and extrude the leg straight took forever, as you will see in the video. The technique I found out at the end is by holding down the Alt key when transforming to create new sections, and by making it into as many small sections as you can. At the end, I apply a blue plastic texture to it in the Fusion's inbuilt render. The last freeform I made was a pillar with a main body making up of 2 sections. The front section was bent forward, creating a housing for the blade, and the rear was shaped for the handle. I then quit out of freeform to incorporate parametric model for the blade. The blade was shelled to 0.5mm thick and assembled in with a rotation limit of 45 degrees. This is the peg where I sketched its outline from an imported canvas and mirrored the extrusion produced directly above it. Then offset a plane in between them to sketch an offset rectangle cutout to be used for both halves. Holes and pins were then produced for assembled joints with limited rotation motion. The second assembly I follow a piston tutorial on YouTube to understand more on the physics of Fusion's joint motions. This model consists of 4 different parts: the piston head itself, connecting rod, crankshaft, and the engine cylinder, which I designed. In order for the piston to move in an up and down motion, the cylinder connecting the crankshaft and the engine cylinder has to be grounded, otherwise the whole assembly will rotate freely in a random direction. I made my own adjustment. Instead of making the whole engine tutorial, I only did 1 cylinder to save time. The last model is my graphics card casing, which was actually one of the first model I produced before we had a class on assembled joints. Because it consists of multiple parts, the top cover, bottom cover, and 3 fans, I made it into a joint function so the fans can rotate in its housing. All the parts were sketched from imported canvas, where the digital diagram and dimensions can be found on the product website. I started with the sketch on the top cover, where it consists the most irregular cutouts. Separated the drilling on a new sketch so I can use them to match the bottom section later on. After finishing the top cover by filleting, shelling, and drilling, I went to model the fan on the side. I used the emboss function to produce the curved surface that linked from the inside cylinder to the outside. Then I thickened the blades and made a circular pattern around the axis. Because there are 2 sizes of the fan, I then scaled the first one to duplicate into a smaller fan. The bottom half was then modeled on another canvas directly overlapping from the same origin, which allowed me to match the drilling to fit. Lastly, it is the assembled joints for the fans, and in order for them to spin simultaneously, the motion link was then assigned for the fans to rotate in the same directions.